Okay, given the following distribution of number of cars in a household, find the expected value and the standard deviation. So what we have here is a discrete distribution, and it's what we call it's just a very general distribution that doesn't follow any pattern such as binomial or Poisson. So to find the expected value is the same thing as finding the mean. And the mean, when you have just this list of values like that, is just the sum of each value multiplied by its probability. So we have 0 times 0.15, 1 times 0.5, 2 times 0.3, 3 times 0.05. And so we can add those numbers up. Of course, the 0 times 0.15 is going to be 0. We can add that up and get 1.25 as the mean. So on average, a household will have 1.25 cars. Not a car can't have exactly 1.25 cars, but again, this is an average. Now, the variance, a little more work involved there. What we need to do is find x squared times p of x, and then find the mean squared. There's a saying for variance. No matter what type of distribution you're dealing with, variance can be thought of as the mean of the squares minus the square of the means. That is essentially what variance is. So in this case, we have to find 0 times 0.15, 1 times 0.5, 4 times 0.3, 9 times 0.05. And if we do that, we did not calculate that one in advance. So 0.5 plus 1.2 plus 0.45, and we have 2.15. And then we need to subtract the square of 1.25. Remember, this is going to give us the variance. And that's going to give us 0.588. So that's the variance. Remember, the standard deviation is the square of the variance. Take the square root of the 0.588. And we wind up with a standard deviation of 0.77 cars. And so that's how we find the mean and standard deviation of a discrete distribution. Even if you have a binomial distribution, these formulas would still work, but they would be unnecessary because you would have to find each binomial probability. You have to find the probability that x equals 1 and 2 and 3 and 4 and however many you have. And then you'd have to take those and put them into this formula. So theoretically it would work, but in practice it's not necessary.